All right, if you're gearing up for your PMMI certification, you already know that industrial control circuits are a huge deal. They can be a real stumbling block on the exam. So in this explainer, we're going to break down the core concepts you absolutely need to nail. My goal? By the time we're done here, you'll be able to look at those questions and tackle them with total confidence. So let's jump right in.
So, you walk up to a control panel like this one. You see a green button and a red button. Simple, right? You push green, and this massive machine across the room just roars to life. You push red, and silence. But how? How do these simple little buttons command all that power? What's the secret logic happening behind the scenes? Well, that's the puzzle we're about to solve together.
Okay, here's our game plan. First, we'll talk about why these circuits are such a big deal for the exam. Then, we'll get into the real heart of it all, relays and contacts. After that, we'll look at the controls you actually touch, the buttons and switches. And we'll wrap it all up with the real magic trick, the seal-in circuit. So let's get right to it. Why do these circuits matter? Plain and simple, it's all about what's at stake on your exam. This isn't just some abstract theory. Mastering this is a straight line to passing your certification. Yeah, these are the big ones, the classic pitfalls that catch so many people out. Confusing normally open and normally closed contacts. We've all done it. Getting totally tangled up in a ladder diagram. Or that one big question, why does the motor keep running? Each one of these is a potential point loser on the test, and we're going to clear them all up. And hey, don't just take my word for it. Instructors who teach this stuff say it all the time. Questions about relays and pilot devices are some of the most frequently missed questions on the entire exam. So think about it. If you can nail this section, you're giving yourself a serious, serious advantage. All right, time to dive into the core components. We're talking about the fundamental building blocks of all this logic, the relays and their contacts. If you get these, you can read pretty much any schematic they throw at you. So what exactly is a control relay? Think of it like a remote control for electricity. You send a tiny little electrical signal to a coil inside. That coil becomes a magnet, an electromagnet, and that magnetic force is what actually flips a whole bunch of other switches, the contacts. There's no physical connection. It's how a tiny signal, like from a push button, can tell multiple, more powerful parts of a circuit what to do all at once. Pretty clever, right? Okay, listen up, because this is probably the single most important rule you need to know for reading these diagrams. It's called the normal state. Now, this is a huge trip up. Normal does not mean the state the machine is in when it's running normally. No way. Normal means the device is completely de-energized, untouched, at rest. Basically, it's the state it would be in if it were sitting brand new in a box on a shelf. Every single symbol on a schematic is shown in this shelf state. You have to get this right. So that normal state rule directly leads us to the two kinds of contacts you'll see. First, you've got normally open, or NO. Think of it as an open gate. In its normal shelf state, no electricity can get through. But when that relay coil gets energized, bang, the gate closes and the path is complete. The opposite is normally closed, or NC. This gate starts out closed, letting power flow right through. But when the coil gets energized, whoosh, the gate is pulled open and the circuit is broken. The easiest way to remember this for the exam: normally open is usually for starting things, and normally closed is for stopping them. Okay, here's another one that trips people up on the test all the time. Control relay versus a contactor. They can look kind of similar, but they have totally different jobs. Think of it like this. The control relay, you'll see it as CR on a diagram, is the brains of the operation. It's for low-power, signal-level logic. The contactor, usually labeled M for motor, is the muscle. It's the heavy hitter, built with massive contacts that can handle the huge surge of current needed to actually run a big motor. Brains and brawn, that's the difference. So we've got the brains of the circuit down, but how do we, the humans, actually tell it what to do? Well, that's where the controls come in, the push buttons and switches that we actually press. And really, you'll mainly see two types. First is the momentary push button. The best example is a doorbell. It only works for as long as your finger is on it, right? You let go, it springs back to normal. Then you have the maintained push button. This is more like a classic light switch. You click it on and it stays on. You have to physically click it again to turn it off. So let's do a super quick cheat sheet for the exam. Green buttons, they're your start buttons and they are almost always normally open. Red buttons, those are your stop buttons, and they're normally closed. So think about it. When you press start, you make the circuit. When you press stop, you break the circuit. Make and break.
And I'm going to say it one more time because it's that important. Normal, always, always, always means the button is just sitting there completely untouched.
All right, this next part is where the real magic happens. This is the concept that pulls everything we've just talked about together. We know we're using a momentary start button, right? One that only works when you're pressing it. But that creates a pretty big puzzle.
Yeah, think about it. If the start button is just like a doorbell, how in the world does the motor stay running after you let go? Do you have to stand there holding the button down all day? No, of course not. And the answer is just, it's a beautiful, elegant piece of logic called the Sealand circuit. Let's walk through this step by step. It's super logical. 1, you press the momentary start button. That completes the path for electricity, and boom, the relay coil gets energized. 2, the instant that coil gets power, all of its contacts flip. And here's the key. One of its normally open contacts, which is wired around the start button, snaps shut. 3, now you take your finger off the start button. But it doesn't matter anymore. The electricity has found a new detour. It now flows through that contact that just closed, bypassing the button you just let go of. The circuit is now holding itself on. It's sealed itself in. It's like a form of mechanical memory. And 4, to stop it, you press the normally closed stop button that physically breaks the entire path, cuts power to the coil, the seal end contact opens back up, and the whole thing resets. Brilliant.
So here's your big exam tip. Write this down. When you look at one of these ladder diagrams, the very first thing you should do is find the start button. Then immediately look for the contact that's wired in parallel around it. That's it. That's your seal-in contact, sometimes called a holding contact. If you can spot that, and you know what it does, you can decode the entire circuit. It's the key to the whole puzzle. And just like that, we come full circle. You look at a panel like this now, and it's not just a scary mess of wires and buttons anymore, is it? You can actually see the logic. You can picture the start button making the circuit, the stop button breaking it, and that one clever little seal-in contact holding everything together while the machine runs. You've learned to speak the language of control circuits. So I'll leave you with this final thought, a little troubleshooting puzzle. Now that you understand the logic, imagine you walk up to a machine, you press that green start button, and nothing. The motor doesn't start. Based on everything we just covered, on that path the electricity needs to take, what's the very first thing you'd check? Thinking like that, like a troubleshooter, that's what's going to help you absolutely crush this part of the exam.